Right, so let's deal with this question here. 4.1.3. 5 marks. Let's see why it is 5 marks. So now, this is a fraction. The question is, determine the integral of y dx. So you're given the question as y is equal to. So you put in your integration sign there and replace this with, replace y with x cubed plus x divided by x minus 1 dx. Alright, so this is your problem. So what you will normally try and do is try and factorize and see if anything cancels here. Okay, that's a normal thing to do. Alright, so you try and factorize. So let's try factorize. So I have x cubed plus x. If I take out a common factor of x, I'm going to be left with x squared, because x times x squared is x cubed plus 1 all divided by x minus 1. The problem is this is a positive. If it was a negative, then I would be able to factorize further. So let me just show you what I'm talking about. If you had x cubed minus x all over x minus 1, then when you factorize, it will be x squared minus 1 all over x minus 1. And then this is the difference of two squares. So you can factorize, that will be x minus 1, x plus 1 all over x minus 1. And then x minus 1 and x minus 1 will cancel. So you end up with x times x plus 1. And then you can multiply it back, which is going to be x squared plus x, and then you can integrate from there. That's only if it was a negative here. The problem now is we have a positive, so this is not going to work like how it should be. Okay, so it's not this example here, we cannot do this. So what do? We need to find another way to simplify. Clearly, the numerator is of a higher degree than the denominator. So what we can do is we can divide. Right? So that will be long division. Right, so long division, you can see you have to know it here in N5, not only in N6. So here's your x minus 1, and then you have x cubed plus 0x squared plus x plus 0. Write it from highest to lowest to avoid any errors. Okay. So now, long division, you all know the rules. I'm not going to go and explain the whole thing again. You can always refer to the partial fractions long division. But basically, it's term 1 divided by term 1 there. So it's x cubed divided by x, which is x squared. Then you will multiply x squared times x, which is x cubed, x squared times minus 1, which is minus 1 x squared. So that is multiplication. The next step is to subtract. So we're going to go top minus bottom. So therefore it's 0 minus minus 1, which is going to be a positive 1 x squared. Top minus bottom, that is going to be a 0 x cubed. 0 x cubed, which is 0. So what do you do next? You bring down. So you bring down the remaining terms, which is plus x plus 0. And then you go back to step number 1, which is divide. X squared divided by x is x. Then you multiply x times x, which is x squared. X times minus 1 is minus x. Subtract. So when you subtract, it's going to be top minus bottom. So that's x minus minus x. That will be x plus x, which is 2x. They are positive 2x. 1 minus 1, 0. You know, you always must get 0 when you're subtracting the first term. Right, always a 0. And then you got the 0 there. Well, you don't have to, right? But you can bring it down if you want to. Let's bring it down. So let's bring down the 0. Now we go back to step number 1. You carry on dividing, okay, until this is smaller, until you have a proper fraction, okay. So 2x divided by x, that will be 2x, 2 times x will be 2x, 2 times minus 1 is minus 2. So that's divide, multiply. Next step is subtract, top minus bottom. 0 minus minus 2 is a positive 2. You know that 2x minus 2x, you must always get a 0. If you're not getting a 0 in the front, there's a mistake that you are making. Right. So now we go back and check, can you divide 2? This is x to the power 0. And that is x, that means this is smaller. So we stop dividing. Right, so this is your remainder. Okay, so how do we write this out? So therefore, x cubed plus x divided by x minus 1 is equal to, we got x squared plus x plus 2. Okay, that is the quotient there, what we worked out. And then you add, you always add, you will put a plus. So you will add the remainder that you worked out here, all divided by the denominator of x minus 1. Right, so how do you make sure that this is correct? You can substitute a value for x into the left hand side and the right hand side and check if they are equal. If they're not equal, then it's wrong. Okay, so you just fast on the calculator. Let's take an example. Like put 3 here. 3 cubed 27 plus 3 is 30. 3 minus 1 is 2. 30 divided by 2 is 15. 3 squared is 9 plus 3 is 12 plus 2 is 14. And 3 minus 1 there is 2. 2 divided by 2 is 1. 14 plus 1 is 15. But obviously you do it on the calculator in the exam to make sure it's correct. So you don't just accept that this is correct, you have to make sure it's correct. You understand that? Before you move on to the next step. Now, all we do is put in our integration sign. So now therefore the integral of x cubed plus x over x minus 1 dx is now equal to the integral of x squared plus x plus 2. We can do this separately if you want to, plus the integral of 2 over x minus 1 dx. And the last part is the easy part here. The main thing is the long division. You have to realize that you have to use the long division. So now I can integrate x squared, which will be x to the power 3 over 3. This is easy, x to the power 2 over 2 plus 2x plus, you know this 2, you can write it in front to make sure that you have an exact derivative. The numerator is 1 and the denominator is x minus 1. The numerator is an exact derivative of the denominator, so therefore the answer is ln absolute value of the denominator plus c. So that was this question from our N5 November 2019 paper. Right, 4.1.4, we have sine multiplied by sine. The angles are different. There's no double angles here. So this is not a 2x. If it was a 2x and maybe an x, then you can use a double angle formula. However, that's a 10x. That's a 7x, so what do you do? For angles that are different, when you are multiplying sine times sine, or sine times cos, or cos times cos, you go to your formula sheet for this one. Alright, so you go to your formula sheet on page 1, trigonometry. And then this is the one that you are looking for. So you're going to go to your formula sheets and you're looking for sine A times sine B. So sine A times sine B is the same as half, and then you got cos of A minus B minus cos of A plus B. Right, so it's all there on page 1. Right, so let's deal with this now. So what is the question? We need to integrate sine 10x sine 7x dx. So all you do is you use the formula first, right? Then you will integrate. So now this is equal to, you can see there's a half there, open brackets. Then you got cos of A minus B. So your A is 7x, your B is, your A is 10x, and your B is 7x. So that's going to be cos of 10x minus 7x, A minus B minus cos of A plus B, which is 10x plus 7x. This is the easiest one you can get under integration. Okay, all you do is copy down the formula, substitute. Let's see what we have. 10 minus 7, that will be 10 minus 7, that will be 3x, and then 10 plus 7x, 17. So you separate them, there are two terms now, and now all we do is integrate. So you integrate cos, you're going to get sine 3x all divided by 3. Integrate cos of 17, that's going to be sine of 17x all divided by 17 plus C. You can leave your answer like this. It's fine, 100%. You don't have to multiply the 2 inside. It's pointless. Okay. So this one, how many marks was this one? How many marks did I write down? 3 marks. This one is only 3. Right, so remember, for sine times sine, sine times cos, cos times cos, when the angles are different. So the key word is angles are different here. Angles are different, go to page 1 and use this. Alright, so next one, 4.1.5, you got y is equal to x divided by sec 3x. So let's put in our integration. So we're integrating x divided by sec 3x. So what do? We have to remember our identities. What is 1 over sine, 1 over cos, 1 over tan, 1 over cosec. In this case, we got 1 divided by sec. So 1 divided by sec is cos 3x times my x. Right, so here, clearly there is no exact derivative. So this is integration by parts. Okay, this is integration by parts. So integration by parts, the formula is f of x, g of x minus the integral of g of x times f prime x dx. How do I know it's integration by parts? It's multiplication. Integration by parts deals with multiplication, where you cannot let u equal to anything. There's nothing that will cancel. If I let u equal to 3x, the derivative of 3x is 3. It does not cancel with x. However, if it was 3x squared, then it is not integration by parts, because the derivative of x squared will be 2x, x and x will cancel. So that's why you must know your differentiation, the table in your head. So now, priority lists. Remember the priority list here. Priority list is for choosing f of x. Number 1 is your inverse. Number 2 is logs. Number 3 is powers of x. And number 5, the last one, is your trig function, which is cos. So from your priority list, this is, let me just put an arrow here. This one here will be number 3, and this here is number 5 from your priority list. So whichever one is higher up must be chosen as f of x. So therefore my f of x is x. Therefore g prime x will be cos 3x. So once I got my f of x, I can find f prime x. The derivative of x is 1, and then to get from g prime to g, you integrate cos. Integrate cos, you get sine 3x all over 3. So once you got that sorted out, then you do the substitution. F of x is x, g of x is sine 3x all over 3, g of x the same thing, sine 3x over 3, times f prime x, which is 1. So that becomes x sine 3x over 3 minus 1 over 3 times, you integrating sine 3x. So that will be x sine 3x over 3 minus 1 over 3 times, when you integrate sine, you get minus cos 3x all over 3 plus c. You're done. So that will be x sine 3x over 3 plus 1 over 9 cos 3x plus c. You're done. So that was our integration by parts example. Alright, so the next question, 4.6. So you were told using partial fractions. Right, so now for partial fractions, similar to the previous example. The previous example was a fraction, but we did not have to use partial fractions because after we used our long division, everything was simple to integrate. Okay. Now here, this is a fraction. X squared minus 1 can be factorized. But the problem here is the numerator is not of a lower degree than the denominator. Okay. If the numerator is not of a lower degree than the denominator, then you will use long division. So you have to use long division again. Alright, so let's write this down, our long division. So we have x squared minus 1. That's a denominator, goes or divisor, goes on the outside. The dividend on the inside, which is x squared plus 0x plus 0. And partial fraction, long division, is just a 4-step process. You're doing it over and over again. The only way you're going to get it wrong is if you make a mistake with the signs when you're subtracting. Okay, so step number 1, divide x squared divided by x squared. You get 1. Multiply 1 times x squared is x squared, 1 times minus 1 is minus 1. Subtract. So that was divide, multiply, subtract, top minus bottom. Top minus bottom, 0 minus minus 1 is going to be a positive 1. Top minus bottom, 0. This was an easy long division. Check. This is 1x to the power 0, which is smaller than x to the power 2. So therefore, this is the remainder. Right, there's no more division. So therefore, x squared all divided by x squared minus 1 is equal to 1 plus 1 over x squared minus 1. Alright, so now with this one has nothing to do with this fraction here. So this is the only part where we're going to apply our partial fraction. So is your fraction. So this part here, let's write them down. This is where you're going to apply partial fractions here. So now let's take this fraction, which is 1 over x squared minus 1. Factorize the denominator, which is going to be x minus 1, x plus 1. This is an easy one. Alright, so you know your denominator is second degree. You're going to have two fractions, two constants. So it's going to be a all over x minus 1 plus b all over x plus 1. And now we multiply by this factorized denominator on both sides. So I'm going to end up with a 1 on the left. A times x minus 1 will cancel with x minus 1. That will be x plus 1 plus b. X plus 1 will cancel with x plus 1. So you end up with x minus 1. Easy one to do this one. So now you will it's up to you. I'm going to use substitution, which is definitely faster in this example here. So I'm going to let x equal to minus 1. So on the left hand side I have 1. Minus 1 plus 1 is 0. Minus 1 is minus 2 times b is minus 2b. So therefore b is equal to negative 1 over 2. My next substitution, I'm going to say let x equal to 1 this time. So I'm going to let x equal to 1. So on the left hand side I have 1. Okay. On the right hand side 1 plus 1 will be 2 times a, which is 2a. And here you know 1 minus 1 is 0. That's why I let x equal to 1, because I want a 0. So therefore a is going to equal to 1 over 2. So therefore 1 over x minus 1, x plus 1 is equal to 1 over 2 divided by x minus 1 plus minus 1 over 2 divided by x plus 1. Right, so now let's do, this is just replacing my a and b. Let's write down the whole thing now. So therefore, the question was integrate x squared over x squared minus 1 with respect to x. So what did we do? We found that after long division we had a 1 there. So there's my 1. I'm integrating 1 with respect to x. And this part here is this part here. You can see that. Plus the integral of half, and that's 1 over x minus 1 dx. Take this, write it here, minus half 1 over x plus 1 dx. Always take your constant, write it in front of your integration sign so you can identify the type if you have an exact derivative. So clearly the derivative of x is 1. Derivative, there's no need for any use substitution. You go straight forward to your final answer here. So you integrate 1, you're going to get x plus half. Numerator is an exact derivative of the denominator, so it's going to be ln absolute value of the denominator minus half ln absolute value of the denominator. That's it. There's nothing more to do. So that was your partial fractions. You had to use long division here. Right, so 2011 paper now we're dealing with. Let's have a look at the questions that came out then. So here 4.1.1, we've got y is equal to the integral of e to the power minus x times sine. Put in your integration sign. We will not write down y here. It's the integral of e to the power minus x times sine x. So you should know whenever it's exponential function times your trig function, that's your special case example. Okay. You should be happy when you see something like this because you know you're only using the formula twice, and there's one way to deal with this. So this is the special cases. Special case, apply the formula twice. Right, so let's write this down. So what do we have? On the left hand side, you got the integral of e to the power minus x sine x. And then you will write down your formula for the first time. Integration by parts. So that is f of x, g of x minus the integral of g of x times f prime x dx. So your f of x, for the first time f of x, so now remember your priority lists. This is number 4, that's number 5. So we always choose what's higher up. So f of x is e to the power minus x. So f prime x will be e to the power minus x times minus 1. Then g prime x is going to be sine x. So g of x, you have to integrate sine, and then you get minus cos. So that is the first time using the formula. So let's do the substitution. So my f of x is e to the power minus x, g of x is minus cos, g of x again, minus cos f prime x minus e to the power minus x. If you want to simplify, you can before using the formula twice. So this will be minus e to the power minus x, cos x, negative times negative times negative is a negative. The integral of e to the power minus x, cos x dx. So here is our integration problem for the second time. Exponential times trig, we do the same thing. So let's set it up. So you got your negative, make sure you open up your brackets. Otherwise, it's wrong. Right? You must open up your bracket because the negative affects all the signs on the inside. So this is going to be f of x, g of x minus the integral of g of x times f prime x dx. So for the second time, let's write it down here. So now, what is my f of x? My f of x here is still e to the power minus x. So f prime x, the derivative here is minus e to the power minus x. Then your g prime x this time is cos. So therefore, to get g of x, you need to integrate cos. And then when you integrate cos, you get positive signs. So all we have to do is substitute. so let's do the substitution. My f of x here is e to the power minus x. G of x is sine e to the power, g of x here is sine x, and f prime x is minus e to the power minus x. So what do? Remove the brackets. We minus e to the power minus x cos x. Now you can see that negative, I told you to introduce a bracket. Now the negative affects everything inside there. So that will be minus e to the power minus x sin x, and then a negative times this negative times the negative again. Three negatives will give you a negative. Right. So remember, on the left hand side you have the integral of e to the power minus x sine x dx. Why did I pause? Why did I not write that down? Because I want to draw your attention to now the question on the left hand side, and look at what we have on the right hand side now. Remember, I'm multiplying a negative times a negative times a negative, which is a negative, and then you got the integral of e to the power minus x sine x dx. We're back to the question. Look at it. The integral of e to the power minus x sine x, the same thing. Can you see that? So what do? You will take this to the left hand side, your like terms. So you got the integral of e to the power minus x sine x dx plus the integral of e to the power minus x sine x dx, and then there's no more integration on the right hand side. So what do we have? We have minus e to the power minus x cos x minus e to the power minus x sin x. So now all we do is add up these two like terms. There's a 1 and a 1 there, which gives me 2 times the integral of e to the power minus x sin x dx is equal to what we have on the right there is minus e to the power minus x cos x minus e to the power minus x sin x. Takes long, but very easy to do. You know, you're only using the formula twice. So therefore, the integral of e to the power minus x times sin x, you divide by 2 and you are done. Don't forget to put plus c at the end. So that was integration by parts, special case. That was the first one. You cannot get this wrong. Right, so let's move on. Our next question, we need to integrate 2 cos 2x divided by sine plus cos. Now, this is a fraction. Is the numerator an exact derivative of the denominator? What is the derivative of the denominator? You got sine x. If you differentiate sine, it's cos. Differentiate cos, it's minus sine. So you got cos minus sine. And the derivative of, the top is not cos minus sine, it's 2 cos 2x. So, when you look at this, you need to think of your N4 trigonometry. Okay, think of proving identities. Right, so you would have come across examples like this in N4 trigonometry, proving identities. You notice the double angle. Okay, so here, your double angle formulas. So we have cos 2x. So from your double angle formulas, for cos 2x, there are 3 formulas. Number 1 is cos squared minus sine squared. Number 2 is 1 minus 2 sine squared. Number 3 is 2 cos squared minus 1. So which one can we use that will be appropriate for this example here. Now look at it now. This last one, it only has cos in it. This one only has sine. This one has both cos and sine. This one is the best one to choose because look at the denominator. The denominator has both sine and cos. So try and choose a formula that also has both sine and cos. So we choose the first one. So cos 2x is going to be cos squared minus sine squared, all divided by sine plus cos. Don't forget about the 2. Now, we use the formula, think of proving identities. Okay, look at the numerator. You got cos sine, it cannot cancel. But what do you need to do in order for you to make it cancel? What do you notice then? There is a minus sign. So, you have a squared minus b squared, which is the difference of two squares. When you factorize it, a minus b, a plus b. So, now here's my 2 here. So I can factorize the numerator. So cos x minus cos squared minus sine squared is the same as a squared minus b squared. So it's going to be cos minus sine, cos plus sine, all divided by cos plus sine. And now you can see that cos plus sine and cos plus sine will cancel. So what remains is just cos minus sine. And then straightforward standard formulas, integrate cos, that will be sine, integrate sine, that will be minus cos plus c. We're done. So that will be sine x plus cos x plus c. So that was the second one. The next one. What do we have here? We have the integral of arctan. All divided by 1 plus x squared. So have a look at that. How are we going to integrate? So here we have arctan. This is inverse trig functions. So when you encounter an inverse trig function, you need to go to your table of derivatives and check now. What do I have here? I have y is equal to arctan. So when you write the minus 1 there, it means arctan or inverse tan. And then you got your function of x, let's call it f of x. So what is the derivative of arctan? So y prime, the derivative here is going to be f prime x all divided by 1 plus f of x all squared. What do we have here? We have y is equal to inverse tan of f of x. What is my f of x? It's x. We got inverse tan. My function of x is x. Right. So let's apply the formula and let's see what happens. So then y prime. So the derivative now f prime x. So if f of x is x, f prime x means differentiate x and write down the answer, which is 1. all divided by 1 plus. So that's 1 plus f of x, which is x and squared. Okay, so the derivative of inverse tan x is 1 over 1 plus x squared. Now, what's going on here with this problem? Now, let's see. So what you need to do is now, you can see the 1 plus x squared in the denominator. Right, you can see it. So that's why it's best you must be familiar with your differentiation, otherwise you get stuck. So now this example is in this formula. Let me write it for you in a proper form, which is, you got your arctan x to the power 1 over 4 multiplied by 1 over 1 plus x squared dx. Okay, so all I did was write it as multiplication. Any division problem can be written as multiplication. Okay, so that's why you need to know how to switch from division to multiplication or from multiplication to division without a calculator. So what do we notice now? We go back. This is, I call it type A, where you have a number, then you are integrating your function of x raised to whatever power it is, multiplied by the exact derivative, which is f prime x. So here n must not equal to minus 1. This is how the formula works. Right, so we have f of x to the power n multiplied by the derivative of f of x, which is f prime x, and then by inspection, if this condition is satisfied, then the answer will always be f of x to the power n plus 1 all over n plus 1 plus c by inspection. So there's no need to use a use substitution if you know how to apply this by inspection. So does this question satisfy this condition? Let's check. We got a number in front, 1, we'll call that k. We got arctan, which is f of x. You got n, which is a number. And then you got f prime x, 100% exact derivative. So therefore, I can go straight to my solution by inspection. So therefore, this is going to equal to k, which is, there's your 1 there, f of x, which is tan x, and then we're going to go n plus 1. So you're going to go 1 over 4 plus 1, which is going to be 5 over 4, all divided by 5 over 4. So this is where I am. And I'm done. Okay, plus c. So that is it. That becomes 4 over 5, and that becomes the 4th root of arctan x, yeah, to the power 5 plus c. So this is by inspection. Now all the examples by inspection can be done by using a substitution. So or you can always let u equal to f of x, which is arctan x. And then you find du over dx, and then what will happen? 1 plus x squared will cancel. You can always do this by using a substitution also. But you can see the most important thing is differentiation. Once you know your differentiation, then you'll be able to recognize what technique to use just within a few seconds. So make sure you know your differentiation off by heart. Alright. What do we have now? 4.1.4. So you notice there's cot times cosec. So straight away, you should know that, as I said, you must know your differentiation. Otherwise, you won't be able to. You'll be puzzled. You'll get confused with the square root x. You'll be focusing on that. Right. The main thing is you must have that table in your mind here. So what do we know? We know that if y is equal to cosec of f of x, then the derivative of cosec f of x is negative cosec f of x times cot f of x multiplied by f prime x. That is the exact derivative of cosec. So when you see cot times cosec, you must remember that that is a result of the derivative of cosec. Okay, now an example is, what happens if I got y is equal to cosec of square root x? Let's test this out and see what happens now. Okay. So if y is equal to cosec of root x, then y prime, this is the formula, the derivative of cosec is going to be negative cosec square root x times cot square root x times what? Times f prime x. So what is f of x? Square root x. So f prime x is going to be half x to the power minus half, which is the same as, we got my minus 1 over 2 cosec square root x cot square root x all divided by root x. There's my 1 over 2, there's my minus 1 over 2. You can see that? I took x to the power minus half to the bottom. It became positive x to the power half. So now let's look at this and let's compare. What is the difference here? The difference here is, okay, the minus 1 over 2 is not there. And this example has square root x and an x in the bottom. So that's an exam question now, it's not straightforward, you can see that. So it's written like that to confuse you and for you to now to check. Now what can you do to manipulate that first? Okay, so what do we know? We have to remember our exponent laws. When you got x to the power a divided by x to the power b, when I'm dividing and the bases are the same, I will write down my base once and then I go top minus bottom. Or I can go 1 over x b minus a if I want to keep x in the denominator. Two ways of looking at the exponent law. Can you see that? So watch here now. So this is the same as cot root x cosec root x, and this is going to be root x, because this is the power 1 and that is the power half, and 1 minus half is half. Can you see that? Okay. So now you can see that it's almost the same, except that you have the minus 1 over 2. So now, so what do we know? The exact derivative of cosec of root x is minus 1 over 2 cosec root x cot root x divided by root x. Okay. This is the exact derivative of cosec root x. So therefore, watch what I'm going to do now. So therefore, what it's supposed to have is a minus 1 over 2 in order for it to be an exact derivative. So if I go and write down a negative 1 over 2 there, originally there was no minus 1 over 2. So what must I multiply minus 1 over 2 by in order to cancel it? By minus 2 over 1. So these two cancel each other out now. Can you see that? So by inspection, what do we have? Let me write this down. So what we have now is we have this situation here of the integral of cosec f of x cot f of x times f prime x dx, and there's your k there. So this is your standard formula. So we got cosec cot times the exact derivative, and you got your number in front there. So this answer will always be minus k cosec f of x plus c. Okay, so now compare. This is by inspection. Okay, this is by not using substitution. If we're using substitution, then we'll do that next, but not at the moment. I'm just showing you the inspection. Once you realize the exact derivatives then you'll be able to get your solution one time. So compare it now. You got your k cosec times cot. When you integrate cosec times cot, you're going to get negative cosec. Okay, so now here, you got your k, you got your cosec times your, cot times cosec times your f prime x, there's your f prime x here, and there's your k. So what is the answer going to be now? It's just going to be minus 2 cosec of f of x, which is square root x plus c. This is by inspection. But don't worry too much about the inspection if you can't get the derivatives. Now, by substitution, what you're going to do here is you can let u equal to square root x. Right, y'all can try that on your own. You let u equal to square root x, find du over dx, make dx the subject of the formula. You'll see x's will cancel, and then you will end up with something like this here. You'll end up with minus 1 over 2. You're going to get cot of u cosec of u du. After I'm not showing you all the steps now because of time, but basically what's going to happen is du over dx will be half x to the power minus half. Okay, then you'll make, this is going to be minus 2 here. That will be minus 2 cot times cosec and then you integrate and get your answer. But let me leave you all to have a look at this. Okay, remember exact derivatives. If I take this and differentiate it, let me just do it here quickly. Let's double check. Okay, let's double check. So if I got y is equal to minus 2 cosec of root x, then y prime, the derivative is going to be negative cosec root x times cot root x times half x to the power minus half. Can you see that? That's the derivative of minus 2 cosec of root x. So therefore, what will happen here? Negative times negative, positive, 2 and 2 cancel. So then I have cosec root x, cot root x, all divided by root x, which there's it, you can see. Right, so that is using differentiation to check. We continue next time.